This is 2015 FRQ number 6. So they give us a Maclaurin series for a function, and they say it converges to f of x. So some function f of x is represented by that Maclaurin series, and they have a raised convergence of r. They want to find r. So just a radius only, not the interval. So what does a ratio test say? I take the limit as n goes to infinity, and we do absolute convergence. So I take my general term here, and I add 1 to all the n's. So that's going to get me negative 3 to the n, x to the n plus 1 over n plus 1. And we divide it by the original, this. But to divide by the original is to multiply by the reciprocal. So we get n over negative 1, negative 3 to the n plus 1, and minus 1. Struggling here. And x to the n. Then we start canceling things. So if you look, that has one more x than that does. So we cancel that, we'll be left with an x. And then if you look, that has one more n on top than the bottom. Actually, one more negative 3. So when you cancel those, you'll be left with a negative 3 on top. And so this will equal the limit as n goes to infinity. Now, negative 3 and x are constants. So I'm actually going to take that out in front. So let me erase this. Absolute value of negative 3x, limit n goes to infinity of n over n plus 1. Well, this is just going to approach 1. So it's the absolute value of 3x. And in the ratio test, when r is less than 1, it will converge for sure. Divide both sides by 3. So we have found our r is 1/3. That is part A. Part B, it asks for the first 4 non-zero terms of the derivative of f. So we learned these are one of the 5 things you can do to a series. If you want the derivative, if you want the series of the derivative, you take the derivative of the series term by term. So the derivative of x is 1, so I'm going to put a 1. The derivative of that is going to be negative 3x. So I'm going to have minus 3x. The derivative of that one will be 9x squared. And they want the first 4 terms. So I'm actually going to need to create more of this. So let me scoot this down. And I am going to take the original function and write it down. F of x is x minus 3 over 2x squared plus 3x cubed minus, I want the next term. So I'm going to plug in what? 0, 1, 2. I'm going to plug in 3 here. So it's going to be negative 3 squared. So that's going to be 9 on top. And I'm plugging in 3. No, I'm plugging in 4. Take that back. I'm plugging in 4. Let me back up here. Because I already have the cube term. So I want to plug in 4. So if I plug in 4 here, I'm going to get 4 minus 1 is going to be 3. So that's going to be negative 27 over 4. And then the exponent, that's going to be 4, x to the 4th. Plus dot, dot, dot. I don't need the general term, so I'm good. So now I take the derivative of the next term. It's going to be minus 27x cubed plus dot, dot, dot. Now here's the question, and this is the hard one. They want f prime as a function. And here's where your knowledge of different types of series comes into play. And we're going to rewrite this, and it's going to start to make sense. First, I'm going to do this. 3 squared x squared, 3 cubed x cubed. Now, if you look at this, you might see something weird like this. Plus minus 3x to the first, plus minus 3x squared, plus minus 3x cubed, plus dot, dot, dot. Then if you look at this pattern, you get this. Now, do you recognize that series? That is geometric, because to get from one term to the next, you multiply by negative 3x. To get to the next term, you multiply by negative 3x. To get to the next term, you multiply by negative 3x. So this is kind of weird. You just have to recognize some of your basic series. So f prime of x, what's the sum of an infinite geometric series? It's the first term, which is 1, over 1 minus r, but r is negative 3x. So we get 1 over 1 plus 3x. So that only converges on the interval from, or 1/3 is your radius. So if you look at this, it's going to be negative 1/3 to positive 1/3. So that will be your function for the derivative. Now part C, we want to write the first 4 non-zero terms for e to the x. This you have to have memorized. If not, you're going to have to create this from scratch by doing the derivative, the second derivative, and just doing all that. But it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot. How many terms do I want? The first 4. Okay, so I have the first 4 terms of e to the x. Then they want to use the Maclaurin series for e to the x to find g of x, which is e to the x times f of x. Well, e to the x we have. But what is f of x? We have that right here. So can I copy that down? Maybe. X minus 3 halves x squared. X minus 3 halves x squared plus 3x cubed plus 3x cubed. Now, we want a 3rd degree Taylor, so I don't need any higher powers than 3. So this is going to be plus dot, dot, dot. So g of x, we want the 3rd degree Taylor polynomial for g of x. So we're going to have to distribute the 1 till we get to a 3rd power. So that's going to be x minus 3 halves x squared plus 3x cubed. Then we have to distribute the x, but only twice because we don't want to get past x cubed, and that will be x cubed. So that's going to be plus x squared minus 3x cubed over 2. Then we're going to distribute this one only once. And why once? Because it's already x cubed. If I went any further, it's going to be higher than x cubed. So I'm going to stop there, and that's going to be x cubed over 2. So that's my 4th degree Taylor polynomial for g. And I need to combine like terms, so I have x. Then I have minus 3 halves x squared plus x squared. And then I have all my x cubes, 3x cubed minus 3 halves x cubed plus 1/2 x cubed. And that is not in a proper form of a Taylor polynomial. I have to factor out the x squared. So what will be left? Negative 3 halves plus 1. And I have to factor out the x cubes. What's going to be left? 3 minus 3 halves plus 1/2. So that is fine for your answer. You don't have to simplify that. But I'm just going to go ahead and simplify this. That's going to be minus 1/2 x squared. Minus 1/2 plus 1/2, so minus 1, that's going to be plus 2x cubed. So that's my third degree Taylor polynomial for g of x. And that's it. I guess I'm done.